Okay, this is another video in the series for Math 1073 for UTSA. In this video, we'll be handling Module 1.2, solving larger systems of linear equations. So for the first problem, we're going to determine whether the given ordered triple is a solution to the system of equations. So here we got three equations in three variables, typically x, y, z, but it could be a, b, c, or m, n, p, just whatever letters, but typically we go x, y, z. So I want to see if these numbers solve all three of these equations. So basically, I'll just pick one equation, plug in the numbers, see what I get. And if all three work, it's the order triple is a solution to all three, well then I'm done. That's a solution. And as soon as it fails to be a solution to one of the equations, then I'm done checking it's not a solution. So I'll start at the top of the list. Hopefully, I don't end up doing two and then the first one and then finding the last one. Oh yeah, it doesn't solve the last one because that would mean that I could have saved myself some time by checking the proper one first. So is this equal to negative 22? Well, 8 minus 45 minus 15. Well, you know what? Unless my eyes deceive me, plus 15. They do deceive. They were trying to. So yeah, this is negative 22. Okay. Almost made a mistake there. So let's check the next equation. So 8 times 2 minus 9 times 9 plus 5 times negative 3. Is this equal to negative 80? Okay, well, 16 minus 81 minus 15. Yeah, that is negative 80. Right, 16 minus 15 is 1. Negative 81 plus 1 is negative 80. Okay, so yeah, that checks out. So let's check the last one. And I have a feeling that it's not going to solve this one. That would just mean that I did this in exactly the wrong order. So, yeah, is this equal to negative 55? So 8 minus 72 plus 9. Is this equal to negative 55? Actually, let's leave that blank for now. So, did I do that right? So 8 minus 72 plus 9. So that's going to be 17. 17 minus 72. So yeah, that's negative 55. Okay. So it checks out. So yeah, this is a solution to the system. Okay. Now with this one, I'm kind of expecting that it won't be, but that's just my expectation. Maybe it will. Maybe they both work out that way. So let's start with the middle one. I don't know. I'm feeling like the middle one might be where it fails. I don't know why. I chose that randomly. It's not like I checked ahead of time. So plus 8 times 9 equals question mark 6. It's a pretty bad question mark, and penmanship counts. So there we go. So just checking that I wrote it down correctly. I believe I did. So negative 40 minus 36 plus 72. Is this 6? Well, that's negative 76. Oh, plus 72. That is not 6. That's negative 4. Right? Let me double check that I didn't make any mistakes. So I got a 5, 6, 8, and I put in negative 8, negative 6, and 9. 5 times negative 8 is negative 40. 6 times negative 6 is negative 36. 8 times 9 is 72. Add these up, I get negative 76. So yeah, okay, cool. I guessed well, I suppose. So not a solution. Now it's possible that I wasn't lucky at all. It's possible that this is not a solution to any of the equations, but I don't know. I was guessing the middle one. You might want to, on your own, go check. Does it solve this one or this one? Because if it solves none of them, that would be interesting. Maybe that's the case. That's a possibility. So here we're going to solve a system of equations. Equations plural. Okay. So basically, I'm going to notice that there's a couple of things. One, in order to solve this through elimination, which is what I think is going to be the easiest, I need to take two pairs of equations, or sorry, one pair of equations, eliminate x, y, or z, just pick one, eliminate it. It doesn't really matter which one. Then pick a different pair of equations, right? You're going to have to reuse one of them, but pick a different pair and eliminate that same variable. And so now you've got two equations in two variables only, and then we can solve the way we did in the previous module. So I noticed that all these coefficients are multiples of 3, which will be convenient. So I'm going to start by taking the first equation and the last equation and take those and eliminate x. So 3x minus 8y plus 5z equals 27, and negative 9x minus 8y plus 6z equals 119. Okay, I'm going to triple the top equation so that the coefficients for x will match. One's 9, one's negative 9, but tripling. Negative 24y plus 15z equals 81. Negative 9x minus 8y plus 6z equals 119. So when I add these two equations together, the x's cancel. I get negative 32y plus 21z equals 200. This we'll say was step 1. Okay, step 2, I'm going to pick a different pair. I'm going to have to recycle one of them, which I'll recycle the top one, but then I will pair it with the middle one. So 3x minus 8y plus 5z equals 27, and then negative 6x minus 9y plus 6z equals 99. Okay, so I'm going to double the top row, top equation, so that these coefficients will match. One's positive, one's negative. So that will give me 6x minus 16y plus 10z equals 54, along with negative 6x minus 9y plus 6z equals 99. Okay. If I add those together, the x's will cancel, so I'll get negative 25y plus 16z equals 153. Okay, so now I've got two equations in two variables, and we can solve these the way we would have in the previous module, well, module 1.1. Yeah, okay. So, step 3, I was about to say, wait a minute, are we in 1.1 or 1.2? We're in 1.2 right now, right? Yeah, 1.2, okay. So I'm going to take those two equations and pair them up. Negative 25y plus 16z equals 153. And pair that with negative 32y plus 21z equals 200. So this is going to be a bit of a pain. We're going to get big numbers, but it'll just be temporary. So I need to take the top equation and multiply by 32, because these two coefficients don't share any factors. Neither do these. Well, you know what? Maybe it'll be easier if I do these. It doesn't really matter. I'll use these because these numbers are smaller. So I'm going to multiply the top equation by 21. I guess that will be a little bit easier. So this will be a negative, is that 525? 25 times 21? Yeah, negative 525 y plus 16 times 21 will be 336 z. Yeah, 336z. Let's try and hit the undo button. Equals 153 times 21, so 3213. Okay, and I'm going to multiply the bottom equation by 16, or if I want negative 16, let's do negative 16. So negative 32 times negative 16, 512. 512y minus 21 times negative 16 is negative 336. Well, of course, that's predictable. It should have gone that way. And then 200 times negative 16 will be negative 3200. Okay. So when I add these together, I get negative 13y plus 0 equals 13. Okay, so I'll get y equals -1 if I divide by -13 on both sides. Okay, so I got a nice convenient number for y. So now I can get a number for z, and I can pick any of these, I can pick either of these equations to get a number for z. So let's do that. Let's say step 4. Yeah, let's do it here. Step 4. So, -25, plug in -1 plus 16 z equals 153. So I'll subtract 25 on both sides. So 16z equals, well, 153 minus 25 is 128. If we divide by 16, we get 8. So y is -1, z is 8. And so now step 5, I need to go back to one of the original equations. It doesn't really matter which one, just gotta pick one. I'll take the top one. So 3x minus 8 times -1 plus 5 times 8 equals 27. Okay, so 3x plus 8 plus 40 equals 27. So if I subtract 48 on both sides, I'll have 3x equals -21. Divide by 3, I get x equals -7. So our solution then will be -7, -1, and 8 is the ordered triple that solves that one. So this is actually the second time working this problem out. The first time, I made a mistake in step 2. When I wrote this equation down, I wrote down plus 8y instead of -8y, and it really threw things off, and I got really huge messy numbers. So later in the video, you're going to see that, and I refer back to, I'm getting worried because this problem, number 2, I had really, really messy numbers. And then in the next problem, it was so much simpler, and so I was really worried I made a mistake, and I had. So just be careful. The mistake was not arithmetic. I just wrote it down wrong. So be very careful to always write things down correctly, and you'll save yourself a lot of trouble. If you start getting really, really messy numbers, you'll see what I mean in a minute in the video. You should start wondering whether you've made a mistake, because the numbers probably should not get that bad. Something to notice on this one. The last equation doesn't have x at all. It's kind of like we have a 0x. Okay, and that's going to happen sometimes. That's fine. It's not a problem. That's, in fact, a good thing. That makes things easier. Because what I can do is take these two equations and eliminate x. And then this one is like, I already had x eliminated, so it makes the problem a little bit easier. So I have 7x minus 4y plus 3z equals -43 minus x plus 5y plus 2z equals 29. Okay, so I could do substitution or elimination. It doesn't really, I'm sorry, overall we can do substitution or elimination, but I want to reuse this with it, so I need to do elimination. I'm eliminating x. So I'm going to multiply the bottom equation by 7 so I can get -7x here. So 7x minus 4y plus 3z equals -43 minus 7x plus 35y plus 14z equals 29 times 7 is 203. Okay, so when I add these together, I'm going to get no x's, 31y plus 17z equals 160. So now I can take these two equations and solve those as a pair. So -4y plus z, which will be convenient having a coefficient of 1, equals -43, and then 31y plus 17z equals 160. So I'm going to multiply the top equation by 17 or negative 17. It doesn't really matter, but I'll go with 17. So negative 68 y plus 17z equals 43 times 17 is 731. I'm starting to get big numbers again. I'm just copying the second equation. So I'm going to subtract these. So I'll get negative 99 y plus 0 equals negative 891, I believe. Yeah, okay. So I'll have negative 99y equals negative 891. So I can divide by negative 99 on both sides. So 891 over 99. That does reduce. So this will be 297, I believe, over 33, which that also reduces. So this is 99 over 11. So this is 9. Let me double check in the calculator. 891 divided by 99. Yeah, 9. Oh, that's a relief. I like that. Okay, so let's go back to one of these equations and get a value for z. So let's go back to this equation that didn't have x in it at all and plug in 9. So this was step 1, step 2. Now we're on, get that neatly. Now we're on step 3. And I should probably do this. Let's change colors here. Just so later it's very clear where one problem begins, the other ends. So negative 4 times 9 plus z equals negative 43. So if I add 36 to both sides, I get negative 7. This is starting to make me worried that I have a big mistake in the other problem. So what'll happen is after I make this video, I will go back and double check all the arithmetic here. And if there's a mistake here in this one, then at the end of the video, I'll go back and show what the mistake is, if there is one. And if not, well, then the video will just end. Okay, but this is making me nervous that was so messy, and then this is not. Anyway, so now we need to find a value for x. So step 4. Oops. Step 4. So I'll take the middle equation. This one I think will be the easiest because x has a nice convenient coefficient. So negative x plus 5 times 9 plus 2 times negative 7 equals 29. Just double checking that I did that correctly. And I think I did. Okay. So negative x plus 45 minus 14 equals 29. So negative x plus 31 equals 29. Subtract 31 on both sides. And divide by negative 1 on both sides. So our solution is 2 comma 2. Of course, x is 2, but I meant to write 2 comma 9 comma negative 7. So there we go. Let's go to the last one. And I'm assuming that this one will have no solution, is what I'm guessing. So I noticed that here, these don't have any x at all. So I guess I will start by just solving this pair of equations. So I'll first just copy them. Negative 4y minus 7z equals negative 16. Negative 5y plus 8z equals 47. I guess I will get a common coefficient of 20 here. I'll multiply the top equation by 5 and the bottom equation by 4. So negative 20y minus 35z equals negative 80. And then the bottom equation I'll multiply by 4. So negative 20y plus 32z equals 100 and what is that? 188. Double check that. That seems wrong though. So 47 times 4. Oh, 188. Cool. Okay. So now I'm going to subtract these. So the y's will cancel out, and I'll have negative 67z equals negative 268. Is that right? Negative 80 minus 188. Yeah, negative 268. Okay. Okay, so then I'll divide both sides by negative 67. So z equals 268 over 67. Okay. So we're back to messy numbers again. Okay, so now I can find a number for y. I guess I'll take, this is step 1. Step 2, I'll take this top equation and plug in for z. So negative 4y minus 7 times 268 over 67 equals negative 16. I'll multiply 67 across the board. So 67 times 4, 268. I guess I should have seen that one coming. Oh, okay. 268 divided by 67 is 4. Okay, well, that's convenient. Okay, never mind then. I'll just divide by 4 everywhere. So negative y minus 7 equals negative 4, right? Yeah, so I'll I'll add 7 to both sides, so negative y equals 3. Make that a nice neat y. Negative y equals 3. And then I'll negate both sides. Y equals negative 3. Okay. So now I need a number for x. So I can take that top equation. This is step 3. X plus, well, y is negative 3, and z is 4 equals 3. So x plus 1 equals 3. So x equals 2. So I get the ordered triple 2, negative 3, 4.